Good day, I'm NESTOR Sayson Jr. from Camarines Polytechnic College's BSCS 2B. So we are tasked to create our own real-life example or problem based on the assigned topic below. And this should be solved using iterative improvement. Since we are group 1, so we are assigned maximum flow problem. Our own real-life example is routing traffic through a network of roads. So you are in charge of managing the traffic flow in a city with a network of roads connecting different parts of the city. Your goal is to ensure that traffic flows smoothly and efficiently throughout the city. One way to approach this problem is to model the city road network as a graph, with intersections represented as nodes and roads connecting the intersections represented as edges. You can then use the maximum flow algorithm to determine the maximum amount of traffic that can flow through the road network at any given time. In our Python code implementation using iterative improvement solving maximum flow problem, we create a class name graph and we define a function named BFS. We will use breadth first search in this function. So we create a function that will return true if there is path from source to sink in residual graph. Also fills parent array or list to store the path. Mark all vertices as not visited, then create a queue for breadth first search. Then mark the source node as visited and enqueue it. Then we create a loop with a standard BFS loop, then dequeue a vertex from queue and print it. We'll get all the adjacent vertices of the dequeued vertex u. If a adjacent has not been visited, then mark it visited and enqueue it. If we find a connection to the sink node, then there is no point in BFS anymore. We just have to set its parent and can return true. We didn't reach sink in BFS starting from source to return, so return false. Then we create again a function named iterative improvement that will return the maximum flow from S to T in the given graph. So this array is filled by BFS and store path. Then there is no flow initially. Augment the flow while there is a path from source to sink. Then find the minimum residual capacity of the edges along the path filled by BFS. Or we can say find the maximum flow through the path found. Add path flow to overall flow. Then update residual capacities of the edges and reverse edges along the path. So in the drive code, and we will create a graph with with weight on their edges, then assign value to source 0 and sink to 5. Then it will print the maximum flow of traffic here. So if we run the program using the graph, the maximum flow of traffic is 23. 23 is the maximum flow using the iterative improvement and solving the maximum flow problem. Thank you.